All right, folks, I want to talk about some Pythagorean relationships in terms of trigonometry. So when we talk about Pythagorean stuff, usually that's referring to this relationship in a right triangle between the lengths of the sides. And so I'm drawing a triangle, I'm putting a little mark there to show that it is a right triangle. And so if we label the three sides A, B, and C, A and B are legs, and C is the hypotenuse, the side opposite the right angle. The legs are the sides that are adjacent to the right angle. If A and B are legs and C is the hypotenuse, then the Pythagorean theorem says A squared plus B squared equals C squared. And so what I want to do is look at this in a couple of different ways. If we had a right triangle that had some points labeled, so maybe let me just make up some P, Q, and R right there, then I could say that one of the sides RQ squared plus the other leg PQ squared equals the hypotenuse RQ. That's not R, sorry. RP, there we go, squared. So I could write it in those terms as well. And so speaking of trigonometry, I want to put this relationship in terms of a unit circle and see what we have there. So let me bring up this page here. And so I've got this GeoGebra file set up where I can change the angle and I get a ray here that goes out. I would like to look at a right triangle that uses the sine, and also this other side of the right triangle would be the cosine, but I realize cosine is also down here. Since we form a rectangle, CG is the same as AH. And so I have a right triangle here, AHC, and so CH squared plus AH squared would equal AC squared. Let me put that in this screen that I had here. And so those letters were what were those letters? A, C, H. A, C, H, where the right angle was at H. And so I had CH squared plus AH squared equals AC squared. Now in the picture that we had, there was a unit circle. Oh, what a beautiful circle that is. Excuse me. And we had an angle alpha there. And so CH was actually the sine of alpha. It's the length of the half chord associated with alpha on the unit circle. And when I say unit circle, I mean the radius is 1. So AC is 1. And AH, this distance here, is the cosine of alpha. It's also the same as this chord that I drew right there, but I'm drawing it to make a right triangle. So let me not draw it right there. So in this right triangle, I could also write, instead of CH squared, I could write the sine of alpha squared plus the cosine of alpha squared equals 1 squared. So there's a Pythagorean relationship. Another way to write this, instead of 1 squared is 1, and one way that people write this is sine squared of alpha plus cosine squared of alpha. But I am totally fine with just writing sine of alpha squared plus cosine of alpha squared and not confusing people with notation. So that's one Pythagorean relationship with the trigonometric names for the segment lengths. If you click around some different things here, we notice that we might also have another right triangle here, AFB, using some of these different trigonometric things. AB is a side as well. And then there's another right triangle. So there are some different right triangles here that you can use the Pythagorean theorem in a manner similar to this to make some different statements.